I think you do get better at estimating with time in the industry, but nothing's ever really going to take the place of having to deal with legacy systems. That business logic is not standard. The analogy I use sometimes is I can't give you a good estimate because you're basically giving me a book to read, and that book is full of math problems. And each one of those math problems is of varying degree of difficulty, and I'm not going to know how difficult it is to solve until I've actually gone through and looked at each math problem.
Welcome to the Forward Slash, where we lean into the future of technology. I'm your host, Aaron Chesney, with my co-host, James Carmen. James, who do we have with us today?
Today we have Dillon Courts with us. Dillon, maybe tell us a little bit about yourself.
Yeah, I'm the Calibrity Platform Engineering Practice Lead. Platform engineering means that I specialize more on the DevOps and developer experience side of things. So I focus on making sure that developers are capable of doing their jobs effectively and efficiently, and trying to make that a pleasurable experience for them.
Nice. How long have you been doing the technology thing?
It's been over a decade now, so like 12 years or so.
Where'd you get your start?
So I got my start way back coming out of college. I wanted to do the video game thing, but I guess it goes back further than that. I guess I kind of grew up with the internet, right? I'm a late 80s baby, so I came of age with the internet, so I was always messing around. So like Napster and LimeWire and AOL instant messaging, Yahoo chat rooms. Like I was spending a lot of time doing that kind of thing. But I never really thought about programming. In fact, I wanted to do dentistry was my first thought. I really enjoyed going to the dentist as a child, as weird as that was. I think I just had a really good pediatric dentist. But
I went immediately to Rudolph there.
I did too.
in the elf that I just want to be a dentist. Yeah.
That's funny. Yeah, that dream died for me when I went and shadowed a dentist. I had a friend whose dad was a dentist, and it was just a miserable experience, like what it looked like he had to do day to day. And then he just being inside everyone's mouths, right? And then he specifically had an older lady come in who was terrified of the dentist and probably hadn't been in about a decade. And she had some cavities, and she was just very, very anxious the entire time, had to use the gas on her. And it just didn't look like something that I wanted to be a part of long term. So that's when I made the decision to not do that. But circling back to programming, my basketball coach my sophomore year is the one who told me that I should try it out. And he happened to be the programming instructor at my school. So my junior year is when I tried it. And we started with some Java, learned some Java, and I fell in love with it. I really enjoyed it. And then my senior year, I was able to do two separate classes. They had like an AP class for computer science, and then they had it was called Computer Science 2, but it was really do whatever you want, make your own curriculum. So I chose to go ahead and make a video game at that time, my senior year. And I was really into Halo at the time. I think Halo 2 was the big game that had come out. So I decided to try to make like my own replica of Halo using C#, and I don't even remember what the game framework was back at the time. But I remember like going out and searching for like clip art or art, like animation strips on Google Images, and putting that together. And like the first time I was able to get like a little character of Master Chief like animating across the screen was like nirvana for me, right? Like my eyes lit up. I was super excited about it. I'm trying to think if I've had that spark doing software development like since that first time, right? Like it's hard to replicate that. So that was really cool. I spent an entire year developing a game, and then I ended up taking it to a game competition at Miami University here in Ohio, and I won that game competition, which was cool. So that's when I decided I wanted to go forward with that. So I went through school at Ohio State, and then ended up working in game development at a small company in Columbus who specialized in casino games on mobile. So they were one of the first. They had one of the first apps in the App Store. It was a blackjack app. It was one of the first apps, one of the first 100 apps, I believe. And because they were so early and the way the App Store worked, it was somewhat of a self-fulfilling prophecy that like once you were at the top, you stayed at the top. And so they were able to maintain revenue coming in off of that app and it was a slot machine app for 5 or 6 years. So I came in as an intern and I was allowed to make whatever I wanted my junior year, after my junior year of college. And so I made this like side scroller beat 'em up game called Sarge, which was pretty cool. So we you controlled them with like an on-screen joystick, and you could punch and jump. It was like a platformer combo, and you beat up these aliens. And one of the other interns we were working with had some connections on Ohio State's campus, and we rented out a like audio studio, and we went in and did voice recordings for the characters, and that was really fun. We tried to sell it for like $1.99 or 99 cents or something, and it didn't really get bought. So then we made it free, and at the time, there were websites out there that would watch for games going free and then put them on a list. So it got put on a list, and when that happened, it hit the top 100 free games for about a week. So I had like I think it was over 1 million downloads on that particular game, and it's not supported anymore, right? But that was a really cool experience. And then I went on to work with that company for 6 or 7 years doing game development, did everything from more blackjack type games, started getting into some server based games, so like casino games and specifically slot machine games that were more server based. So you would like hit a button on the screen to spin your slot machine, and that would hit our server. Our server would calculate your result, and then we would send it back down, and then the screen would be responsible for painting it and making it look like, that was randomly coming up at the time, but that was all predetermined, 3 or 4 seconds earlier based on the result from the server. So like trying to come up with different algorithms to create different slot machine type results was fun, and trying to make sure that the return was correct, right? Because you can't have like a return over 100% or that person's not losing credits. And that was the whole way that we made money, is you lose credits and then you had to buy more credits in order to keep playing. But it wasn't real money. It was all fake money. I was never really able to figure out like what the profile was, the type of person that was willing to spend money to do like fake, right? To get fake returns and fake earnings. But people did it. So it was fun. It was a really small shop. I hadn't had any experience like on the infrastructure side of things. So that's where I got into that. We ran our own private cloud. Containerization was like starting to come of age, but before that, it was trying to figure out how to replicate some of what Amazon had done with AWS and the infrastructure as a service. Well, we wanted to run our own private cloud and enable us to spin up like virtual machines on demand instead of having to go configure them. So we put together like our own private cloud built out of, it was like 20 different servers. It was just commodity hardware, and we bought these 5 IKEA cabinets with like four drawers each, and we put a computer in each one, which was our server, right? Connected them all together, and we ran the OpenStack software on top of it. So I was a part of that. That was really cool, being able to see and be a part of like getting to a place where it's self-service to stand up a virtual machine was really neat. I got my first exposure to configuration management tools. Like we use Chef to set up all of our different virtual machines with the dependencies we needed. We built an entire microservices architecture. I use kind of quotes around that because it was only a single database that backed all of it, but we did all that in Python. So that was really fun. As I mentioned, really small shop, only like 3 or 4 of us. So I wore a lot of different hats there. I think I published 20 different games while I was there for 6 or 7 years. We did some fun like endless runner type stuff too. When Flappy Bird was all the craze, we were trying to figure out, we challenged ourselves at one point to figure out how to put out a game like once a month. Like what's a 1 month cycle? Could we get a game out? And we did it 3 months in a row. We put out a game that was like about the depth of Flappy Bird, if you remember what that was, where you just like tap on the screen, right? And you're just going through these obstacles. And so you're just endlessly moving left to right across the screen, and there's obstacles in the way, and you have to make your bird float up and down to get past the obstacles. So it was like that level of game. So not a ton of depth, but it was fun. My favorite one we did, I think, was called Block the Rock. There was this character who, it was like set in, it was supposed to be Pompeii, I believe, and there was this like Roman looking guy running down a mountain, and in the background the volcano was exploding, and there were all of these rocks that were falling, trying to hit that character as they were running down the mountain. and you would have to try to draw a line above him to like drop to block the rocks. But you could only draw so much line before your meter refilled, and it got more and more difficult as it went. That was probably my favorite like little one that we did. That was a one-off quick one. But anyway, towards the end of that career, or that part of my career, we started to have trouble with some of the other larger companies, like AAA game companies got into the space. They outcompeted us on marketing big time, development resources big time, and we were just having a hard time staying afloat and bringing in the revenue we were previously. So things were slowing down, and I was realizing that I had gotten really good at releasing software and like building things and figuring out how to do that, but I had really hardly any classical training in terms of figuring out, in terms of like good practices, right? Best practices around software engineering. I hadn't really had any exposure to that, so that's how I ended up at Calibrity. I was looking for a company that specifically specialized in that, so that I could surround myself with folks who could help me learn and grow. And I've been here for 6 years now.
So how did your parents take the news when you broke it to them that you wanted to build your life around making games?
I mean, they didn't understand it, right? They never understood why we would spend hours and hours in the basement when I was in high school doing LAN parties, playing Halo or whatever. Like, I don't think they ever really understood it, but they gave us enough rope, right, or enough of a length to go do what we wanted to do. I think they figured it's worth trying things in your 20s, right? See what you like, see what you can do. You got some time before you really got to buckle down and have a family, and you need to support. If all you're worried about is yourself right now, then go take a chance. Why not? So they were relatively supportive.
So I'm guessing the rest of your family is not technical.
My parents are not. I've got a younger brother who is, and a middle brother who also is not. Yeah.
What do your parents do?
So my parents, my dad works in the construction industry. He works mostly in like framing and drywall. So definitely a different industry than software development for sure.
You both build things, I guess. Something to that, right?
Yes, we both build things, no doubt about that. It's always interesting talking to him about estimates in the software space specifically. He has a hard time understanding why estimates are so difficult for us to come up with from his perspective, right? He gets a plan from an architect. He knows what the square footage is of the building. He takes a look at that and he's like, okay, I know I need to hang 1/2 inch drywall. I can break down based on the square footage of this room and how high the ceilings are. It's going to be, 100 sheets. I know my guys can hang about 10 sheets an hour. Don't hold me to these numbers. So I can break that down, right, and give you a pretty good range for getting that done. But software development is definitely a little different, right? There's an art to it. I think we're a fledgling industry a little bit. We haven't been around as long. We're not as mature. There's not as much standards, right? Like we don't really have the concept of 1/2 inch drywall or 2x4s. Everything's built a little bit differently. So there's always a lot of learning. I think when you go into especially a legacy environment, trying to figure out how they built things. And it makes a lot of sense. All of these organizations, as technology has progressed, like business needs haven't slowed down. So whatever was available at the time to solve the problem, they might have built their applications or their infrastructure out of in order to meet those business needs. But then technology hasn't stopped evolving just because it is such a young industry. It's only been around about 50 years. So there's not as much standardization yet. I mean, maybe that's something we'll see in the next 50 years or so. Maybe we'll start to standardize on a certain set of smaller set of programming languages that everybody uses. But I don't know. We'll see. It still feels like it's pretty young.
So do you think that as languages standardize to maybe like a core set of languages where maybe you only have a few different options, like using the building example, wood studding versus metal studding for your walls, do you think that our estimates will get better with that, or do you think it's more time in the seat and experience in the industry that's going to lead us to better estimates overall?
I think it's both. I think you do get better at estimating with time in the industry, right? I think that definitely helps. But I do think standardization is a big part of it. If we were able to get to a place where, like you said, wood or metal framing, like those are your only two choices, you can get very familiar with both. You can be very proficient in both. Then it's a lot easier for you to estimate. But nothing's ever really going to take the place of having to deal with legacy systems until even legacy systems that are built with a standard framework or a standard language that you're very familiar with. That business logic is not standard. You still have to read it and comprehend it if you're going to work with it before you can make changes to it. The analogy I use sometimes is I can't give you a good estimate because you're basically giving me a book to read, and that book is full of math problems, and each one of those math problems is of varying degree of difficulty. And I'm not going to know how difficult it is to solve until I've actually gone through and looked at each math problem. Right. So it's really hard for me to estimate without spending the time to do that up front.
Yeah, working with a legacy system is kind of like the movie The Money Pit, right? It's you give that initial estimate in 2 weeks. It'll be 2 weeks, and then you get into it, things start to happen. You're like, whoa, this is way different than what we thought, or we found that the wiring behind this wall is ancient and a fire hazard. We got to go in and replace that type of thing, and
Mm-hmm.
then that just moves your estimate time and time again, and it's just another 2 weeks on top of another 2 weeks.
Yeah,
And
and I don't know how you solve for that. Sorry, James, go ahead.
yeah, no, I was going to say, and then at some point the bathtub falls through the floor, and you can only thing you can do is stand there laughing at it. Yeah, yeah, that's maybe Dylan has never seen this movie. He doesn't look like he gets the reference.
Yeah, well,
Which movie is this for
The
our
money pit.
audience? The
The
Money
money
Pit.
pit.
Okay.
the money
It's called
pit.
the money.
Yes.
Tom Hanks, and I don't even remember who the other person was in that.
Oh, it. What was her name? Unimportant, but yeah, it
I don't
was.
know.
Not that she was unimportant, just that it's not
Right.
relevant to the conversation. Uh,
Well, so what would be interesting is, like you mentioned, like the standardization stuff, Dylan. Like, and I don't know, it'd be interesting to investigate this. Like, back in the day of construction, did people go, attempt their construction projects, and they're like, hey, what if we don't use wood for these support structures, and or maybe we don't do 2x4, we do 3x8 or something like that. Like, did people just get creative and like decide, hey, let's do something different every single time we build something? I don't know. That would be an interesting thing to investigate, because that seems like what we do in software. It's like what we want to do.
That's an interesting take. I'm trying to decide, like, do people even have the capacity to do that? And there's more risk back then too, right? Like, you probably don't want to try out something brand new if you're trying to build a house for your family to live in. Like, do you really want to take that risk? So, so maybe that's a luxury software developers have when we're working for other companies and they want to build something, but hey, we also maybe want to learn a new technology so that we're more useful in the future. Resume driven development. We've definitely seen plenty of that.
well, I
Yeah, it's
think it
easier.
starts from education too. I mean, you've got trade schools and and a master and apprentice type system set up in carpentry and that kind of thing that kind of teach you the way that it's been done and should be done. And there's not a lot of that structure that we see in software development. A lot of times you come out of school, you're thrown into a job and just expect to know how to do it. And so there's a lot of self-learning that has to happen. You find certain places that do foster to, all right, we know you just came out of school. We're going to put you underneath this guy that knows his way, and he'll kind of, walk in his footsteps, and you'll be okay.
Yeah, I couldn't agree more with that. I can only speak to my education, right? Like, I have a 4-year degree in computer science engineering, but I was taught next to nothing about best practices and how to develop software. I was taught how computers work, like how programming languages work. I built a compiler, like that was part of my curriculum. But no one ever told me, yeah, your code is good, or yeah, your code is easy to read, or it's clean. Like that was never part of the conversation or part of the criteria that I was graded on going through school.
But you knew the big O notation and how to say how long it was going to take this thing to sort a list of numbers, right?
Yes, yep. And I learned some sorting algorithms. I don't know if I could recall them all. Merge sort, quick sort. I remember some of that.
Mm-hmm, mm-hmm.
The bubble sort
But
was always my favorite,
yep,
just
bubble
because it
sort.
had bubbles.
Yep, for sure. I think another thing, James, you mentioned like people trying things. I think there's like the aspect of it being virtual. Like you can't see what we're working on in terms of when we're doing software development a lot. So I do wonder if people are more likely to ask for changes. Like your stakeholders are more likely to ask for changes because they don't have a good concept of how difficult it is to make a change, and it's hard for us to explain it too. Sometimes it's super easy. Like our stakeholders might just want a button changed from green to blue, but sometimes it's super difficult. They think they're asking for something simple, right? Like I just want my can you just move my login page further in the flow? Well, that's going to take me 3 weeks to do. Well, why? That's really hard to explain. Whereas like if you're building a house and you've already put your put your second floor on, it's going to be really hard to restructure that and move your bathroom to the other side of the house, right? Like no one's going to ask you to do that because the plumbing stack's already in place and they understand the costs associated with that.
And that's kind of like those restoration things that you see on the TV shows. It's like, oh, well, we planned on putting a bathroom here, but we didn't realize that the plumbing stack is on the other side of the house. So
Right.
there's no way we can do that. Um, and that's kind of like one of those things. I also kind of, when talking to stakeholders, you have to change the way you speak. Like if you're telling another developer, you know, something, but then you have to talk to a stakeholder about the same thing, you have to use what I call manager speak and put it in terms that they'll be able to understand without getting too technical and losing them. Because all of us have known, like, that person, you start going off on a technical tangent and you just see the eyes roll back into the head and they just kind of go into like zombie mode because they have no idea what the heck you're talking about.
Yeah, you have to build your analogy repertoire. It's so incredibly important if you want to be able to have those conversations effectively. I tend to fall back on the construction analogies quite a bit because I find that they can be universally understood, but it is so important.
I do the same. As a matter of fact, I just gave a talk on the house building analogy for software engineers.
Yep.
It's definitely a natural one. It's the classic, right? That's kind of how we always do it. But it is interesting how there may be some parallels, but there's also, as we were pointing out just through this conversation, that it really isn't the same in many ways. Also, right? I mean, you're dealing with tangible physical things when you're building a house, but in the software world, we're dealing with virtual things. Um, so, yeah.
And that crosses over even into the engineering aspect of our work. We don't operate as traditional engineers in many cases. Like Dillon, how have you seen that maybe the way we operate as software development teams might be different than, say, your standard engineering practice of, getting, requirements to build something for an engineering purpose, say a bridge or whatever, compared to what we usually get for software.
Yeah. Well, I think we used to try to build software in a similar fashion, right? That was the whole waterfall take on software development was let's gather requirements up front and figure out how to build everything, assuming that all those requirements were correct. And we've moved into more of an iterative approach to software development, which I think is for the better, trying to figure out how to get usable software in front of our stakeholders and our customers as often as possible, and then responding to any feedback we get there. And I think that works well for software because it is malleable, right? Like we can make changes. It is virtual, like we've talked about. So there's not as much material waste there. We don't have to throw away material if we were to make a big change. But there, you can't get the time back. There's still time that is spent engineering and developing that software. There's still you're still gonna have to do to refactor things and change things around. There's the the I guess the issue that you might introduce a bug, right, or multiple bugs when you're doing that refactor, which I think is misunderstood a lot, especially by stakeholders when they ask for sweeping changes. So those are some of the things I can think of off the top of my head. But Aaron, I know you have a background in what is it, electrical engineering? So I mean,
It
I'm sure
was
you have a perspective on this too.
it was more mechanical, but
Okay.
yeah, I came up as in automotive automation systems and tooling, and yeah, our process was basically we would get requirements from a manufacturer, and that we had to be able to produce a certain number of vehicles in a certain amount of in a section of the plant. So, for instance, we were working on an SUV, and we had to produce so many of the body sides in a certain amount of time, and they gave us all those parameters. It was like, okay, you've got a minute and a half to do all of the processing for this body side, and it has to be able to do this at a certain number of jobs per minute or hour or whatever it was. And then our designers would take that information and they'd kind of get the layout of, okay, this is how many stations we're going to need because we can do this many welds in this amount of time and so on. And they'd basically take a piece of onion skin, which is like tracing paper, and sketch it all out and lay it all out, and they pass that off to a layout guy, which was similar to like our designers, and they would produce an assembly drawing that was all the pieces kind of put together, and then they'd pass that off to a more junior draftsman that would detail it out. So they'd basically trace and lay out the individual pieces, put the dimensions on it so it could be built. Then that would go to a checker, and they would open up a vein and put red all over your drawing and hand it back to you and go, okay, fix all those things. And you would iterate over it that way until they finally gave it their blessing. You'd roll it up and ship it off to to the shop floor to be built. And then they would put it together. Once everything was done, you'd run your full test of the line, usually in like a clean facility that it was just that part of the line, and they would have some test parts that they would load in, and you'd watch it run, and the customer would sign off on it, and then they would tear it all down and ship it to the factory, or assembly plant in the automotive sense. And
Did
then we
you
would
ever
do this again over and over again.
did you ever have any issues getting from the design, like when you went to go build it, right? Where what you thought was going to work or didn't end up working when you actually got into the building phase?
Rarely, um, because there was in order to get to the different levels, you had to have a good amount of time in seat of knowing how these systems were put together, and a lot of it was carryover. Um, if you were working on a brand new model, it would be like a first time thing, but a lot of times it was just a new model year. So if you think about the changes from, a 2022 vehicle to a 2024 vehicle of the same name and brand, there's not a lot of differences. Maybe they added some different curves to the body or something like that, or maybe they gave it a little more cabin space, whatever marketing decided was going to make the car sell better in 2024. And so a lot of that would be, okay, here's all of our carryover parts that we can reuse, and these are the ones that we just need to adjust for the new body. So there was a bit of like refactoring there, and you're dealing with steel, so there's a lot of like grinding and chopping and things. It's like, okay, we don't need this here anymore, so we're going to chop out this section, and we're just going to weld in a new piece here, and that kind of thing. Um, and there are times where you would get it to you'd actually get all of your stuff assembled, and then you'd have to debug certain things because they didn't quite fit or the clearances were just slightly off. So you were like hitting into something or just wasn't sitting just right. So you'd have to make some adjustments. But that was mainly done by the guys that were building it. So those wouldn't end up making it back to the drawings because it was already built. So a lot of the defect fixing in post we actually didn't see because it's like, well, this needs to move down an inch, so we're just going to yank this plate and weld it down an inch and reattach it, and it'll be fine. Um, so yeah, there was some of that happened. I actually had the opportunity to do some offline welding robot programming, and Uh, one of the things so there's 8 joints on a robot, and you would get what was called a singularity. And what would happen is when it would try to resolve to a new location, it would hit the hard stop on a joint, and then it would just whip itself around to get to the angle from the other way around. Which, if you can imagine, if you're in a tight space with a lot of different machinery, having a robot just whip a 250-pound weld gun around the room is not exactly a sought after response. So usually when you download the program for the first time, you kind of have like the safety circle around a robot and just have it run through so you could watch it to see if you had any of these singularities where it was hitting a hard limit and then flipping itself around, just so that we wouldn't damage all of the other things, or the hundreds of thousands of dollars in robot that you're working with. So
That's
yeah,
great.
there were some things like that were just uh, you go to download and it's just, oh, that did not work. I got to go back to the drawing board on that one, literally.
That's crazy. That's super interesting with the robots. That sounds dangerous.
That's why there was gates around it. It's like everybody is outside the reach of the robot. Okay, hit run, and we all just kind of winced and held back. It was like, okay, please run, and you'd see it go in, and you had like these small adjustment spots where it was coming in and doing the fine adjustments to get just right. Um, and you're like, okay, and then you hold your breath as it paused for the weld, and then as it comes back out, you're like, okay, and then it does the fast motion. You're like, oh, please, and then singularity happens. You're like, ah, dang it, because usually it was in the motion between point A to point the long traverse that it would end up hitting a singularity because that's where the big adjustments were happening.
James, do you have any perspective on software engineering versus other engineering disciplines?
Well, I mean, it kind of struck me a little bit as Aaron was talking about it. I mean, especially in the automotive industry, you're trying to optimize for repeatable processes and building the exact same thing many times to a very high degree of specification, right? That's just not our world, right? I mean, I don't know. Have you ever built even anything that looks maybe somewhat the same? But I mean, have you ever built the exact same system for multiple customers ever in your career?
I have not, no, right? Like it seems like they can be tangentially similar. A lot of times they have similar layers, right? Like we have an API layer, we have a front end layer, we have a like infrastructure behind it generally. But yeah, the business logic is very unique.
Yeah,
Absolutely.
patterns tend to seem to be the same, but the actual problems are always different.
Right.
Or there's always that one nuance that catches you for a week or two. That's, oh, well, this is different.
So let me pose a question because I feel like the people outside of the software engineering industry they still struggle to understand that because there's something we can do better as an industry, like in terms of explaining this or helping bring to light like why it is different and like what the difference is.
We need street artists to start painting murals of code. But yeah, I mean, it's basically it's one of those things where we need to have an understanding that this isn't just throwing numbers around and typing in a bunch of code and then it just works and that's all we do. There is an art and a craft to what we do, and getting that understanding out there as it is a mixture of right and left brain, because you need the creativity to think of new solutions to upcoming problems that haven't been thought of before. For example, the in the last 6 months to a year, AI has been the big thing. Well, now we need creative solutions for how do we integrate AI into the types of problem sets we've been working in to get to that next level. How can we use this that in a way that will be beneficial to our customers in promote their systems to the next level. And that's all creativity in artistic form. Is It's really thinking outside the box, which if you're in a job where you're doing the same type of thing over and over again, you're going to see the same problem over and over again. You just adjust some of the parameters of what you're building. And that's what I saw from inside engineering. Yeah. Oh, okay. It's another car body. Okay. I already know how to do this. It's just this. Build it backwards. Blah blah blah. Boom, boom, boom. It's done. It's the numbers in the components may change a little bit, but the process doesn't change. There's not a lot of creativity on how you do that until you get those rare edge cases on being able to um, solve that problem. But for us, because technologies continue to change over and over again, we have to be creative about how we can implement those into our solutions for customers because they want the latest and greatest.
Yeah, I think I keep coming back to like the difference between pure greenfield development and legacy systems too. Like trying to estimate a greenfield project is a lot. It's a lot easier. You don't have any dependencies. You don't have to try to read all that code. So I've had success doing that with teams too, being pretty darn accurate within a week or two, which is about what you would expect in like new construction and stuff too. I mean, let's not pretend that construction doesn't ever go over either, right? Like projects are very late at times, 6 months to a year, so they're not perfect either in other industries. But I think one of the biggest problems we have is the legacy aspect of what and the dependencies aspect of what we have to work with.
And I think that boils down to the unforeseen, right? And it's why restoration projects are, even in construction or with anything, have that risk factor of the unforeseen. And it's the same thing with legacy systems. You don't know what's wrong with it until you dig into it. Um, Even exploratory surgery is the same way. They don't know exactly what it is until they get their eyes on it and can see the problem. And I think legacy systems have that buried in a bunch of code to where you may not uncover it for 6 months after you start a project.
Well, did we think we arrived at a place where you asked a question, kind of a call to action almost of how can we do a better job of explaining what it is we do. The problem, Aaron, I think with because I take the same approach you do of like, oh, there's art to it and all of that, but I think it kind of falls on deaf ears because that perception that it's just a bunch of number geeks with slide rulers and all that stuff that are doing this programming thing. It's almost self-serving. It's like, oh, you're just trying to make yourself sound like something fancy when you're not, right? Like, come on, you're just a geek or a nerd, right? Um, I don't know. I think maybe some of there does seem to be more of teaching kids about coding. So there may be more of an empathy there that people have some familiarity with it because I think it's very opaque to the majority of the population right now that they just have no concept of what it even is that we do. So maybe that's part of it, and maybe it'll get better over time as more people get introduced to it. I don't know. What do you guys think?
I think there's some truth to that. I also think it's getting more accessible, right, for people to to do some of the things that they could not do before. If you want to go create a website now, you don't have to have a whole lot of programming like or knowledge. There's so many tools out there that you can just slap some stuff together. What you see is what you get. You have a basic website. There are lots of people that have done that. And there's also people that have made a living out of using those tools to make websites for other people because they don't even want to get to a place where they're doing that. So I don't know. We'll see if AI ends up making us all obsolete or if we just continue to get better and better at building tools that allow people without the technical skill sets to solve the problems they want to solve.
And I also think that with the accessibility and making it more accessible, people will stop with the stigma of well, you have to be a genius in order to be able to do what we do. I was actually talking with a gaming group that I play with, and they want to produce their own mods and stuff. And I was talking about coding, and they're all just like, "Oh, that's so beyond me. You got to be like genius level to do that kind of stuff." I'm like, "No, actually, you don't. If you break it down a certain way and you kind of follow a certain amount of steps, it just becomes researching the how. You know, the what is very approachable. If you think about coding in a way of from like a pseudo code kind of manner, it's like, well, I need to do this first. Once I have that, I can do that. Oh, I forgot to do this, so I'm going to put that back up here. And then you just kind of piece it together, kind of like you would a jigsaw puzzle. Oh, I'm going to start with the edges, and then I'm going to start filling in the different pictures. And you can
Yeah.
approach coding that way and make it more accessible. Languages like that are visual programming ones. There's a few different ones out there where you just have like little code blocks. You just snap them together, and it's usually meant for like elementary level like coding exercises and things like that for teaching kids how to code. Those things are awesome. I love those things.
Well, I'm not letting any of my family listen to this episode for sure because I have them all fooled to think I am some sort of super genius. So I really I kind of dig them, that aspect, and I don't want them to not think I'm a super
Well,
genius anyway.
those of us that are, we recognize our own.
Right, right.
You're
I
right.
mean, you all know I'm not. You guys can see right through it, but my family doesn't have anything to do with this industry. You all know I'm not a super genius, of course. All right. Well, I think we've definitely appreciated your time today, Dylan. But we do have a little thing we do every now and then. We call it the lightning round. I mean, we really get down into the nitty gritty of things with this and real questions. When it comes to APM tools, are you a fan of using more open source and kind of wiring everything together your own, or buying off the shelf commercial products?
Am I allowed to say it depends for these hot take lightning rounds? Is that an acceptable answer? Do I have to be super concrete about it? I think I'm I think it does depend, right, for this particular one. Most of the time I'm going to recommend buying an off the shelf tool. And I think most organizations, it's hard to get them to want to invest in performance monitoring, application performance monitoring anyway, right? When you tell them that they have to stand up an entire team to do it correctly, and invest in learning these open source technologies and building out your own dashboards, that's a pretty tall order and a tall ask. So it's very easy. These application performance monitoring tools have gotten pretty mature. Your Dynatraces, your Datadogs, your New Relics. Yes, they can be expensive depending on how big your organization is, but I think what you get out of it is well worth it. It's often plug and play, right? And you get things like distributed tracing out of the box. You get alerting out of the box. They'll do analysis and find discrepancies if your latency looks different than your baseline. Like, there's a lot of really cool functionality that it would take you quite a long time to build using open source tools.
And for those playing along at home, APM stands for Application Performance Monitoring.
All right. So Kubernetes or like ECS?
So again, it depends. I'm going to lean towards the ecosystem on this one. So I really like the ecosystem around Kubernetes and what you get there with the open source community. Helm charts, you can just plug stuff in, whatever you want to deploy. Someone else has probably already built something out for that, right? ECS is definitely simpler, but you're also tied into that Amazon ecosystem, depending on how you feel about that. So I would lean Kubernetes most of the time, unless you just really don't have the resources or have no familiarity with Kubernetes. But it's become not as much of a concern management of large Kubernetes clusters with the managed offerings you get from the large cloud providers now. They do a lot of the heavy lifting for you.
Java or .NET?
Oh yeah, softball. Again, I'm going to fall back on the ecosystem part. So I'm going to lean towards Java. I like .NET a lot, but for me, like programming languages really aren't that important. I feel like learning the programming language is the easy part. The hard part is often the ecosystem around the language, right? And what you get from the community. And .NET has some decent support there, but a lot of it you're also dependent on Microsoft for. Java having more of the, I think, an open source community around it. There's just a lot more available to you, and I think it's more robust. So I'm going to take Java.
All right. Star Wars or Star Trek?
Oh, that's easy. Star Wars. I don't think I ever really watched Star Trek. I might be too young for that.
Well, they had multiple generations. I mean, they've had like, I don't know, 10 generations of Star Trek. They can try to reignite it every few years.
Yeah. How's that going for them?
Not great. All right. Walking Dead or Game of Thrones?
Oh, Game of Thrones for sure. Game of Thrones production quality is just so much better, right? Walking Dead I wanted to like a lot, and like there's some good stuff in there, but the production quality is just not nearly as good. The acting is not as good. It's just they're not even in the same league, in my opinion.
I will have to say that the Walking Dead, like one of the early episodes where, you know, Rick's waking up in the hospital and realizing the world has gone to hell around him. When they redid that, they usually do it around Halloween, or they would do it around Halloween, where they'd play the whole thing in black and white. Watching that particular episode in black and white was really cool. So I do like it, but I am more of a Game of Thrones fan. All right, and let's end on the really important Coke or Pepsi?
Definitely Coke. I don't drink a lot of pop in general, but the only thing I would ever drink from Pepsi might be Mountain Dew. So definitely Coke.
Yeah. I mean, this is America, so yeah. I mean, Coke's the right.
Get all hopped up on Mountain Dew.
All right. Well, I think that's it, Aaron.
So that's all we have time for today. Thank you to our guest Dillon, our production staff, and my lovely co-host James Carmen. This has been the / where we lean into the future of IT. Thank you, and stay tuned for the next episode.